Okay, so looking at these two problems, our first big tip-off is we know these are big little logic because we have a limit as x approaches infinity. When we see that, we say, we know we're going to sub in infinity, but you can't because it's not a number. So instead, we're going to sub in big. So when we do that, what do we end up with? Well, this is a really fun one because we end up with the square root of 9 big squared plus 4. That made my little square root a little too large. Plus 4 on the outside. 2 times big minus 4. And now our logic kicks in just like the other problems, except we just have to be a little careful because of the square root and what that will do to variables, due to bigs, due to whatever. But inside the square root, we're still going to manipulate like normal. We're going to say, okay, big squared. We're going to leave that alone for a minute. We're just going to say that's the same thing as big squared plus 4. Right? We don't really need those parentheses. Now, but what becomes really fun here is we're going to say, all right, well, inside the square root, 9 times big squared. Well, that 9 is important, but the plus 4 is not, right? That plus 4, if you had infinity dollars, whatever that number would be, 10 bazillion dollars squared, that's even bigger, times 9, that's even bigger, plus 4, don't need it. So the 4 goes away. But the 4 on the outside, we're going to leave it there. Just because that's not under the square root and we can't play this game yet, that square root kind of changes things for us. So then down here, we're still going to have 2 big minus 4. Okay. Now, because we don't have adding or subtracting inside our square root any longer, now we can simplify that square root. We can say, what is the square root of 9? Well, square root of 9 is 3. What's the square root of big squared? Well, the square root of big squared is the same thing as like saying what's the square root of 9 squared. Square root of 9 squared is 9. What's the square root of 12 squared? Well, that would be 12. So what is the square root of x squared? Well, that would be x. So what is the square root of big squared? Big. Plus 4, right, for this plus 4, divided by still the 2 big. And if we wanted to, we could say, look, 2 times big, we need the 2, but the minus 4, we don't need that, right? It doesn't matter. When you have a bajillion dollars and someone says you have to pay 4, you're like, fine, take it, don't care. Now, similar logic to that numerator. We've simplified that square root, which broke out this 3 in the big, and this plus 4 can now go away. So what we're left with is 3 big divided by 2 big, which will result in 3 halves. Okay, so let's take a look at this problem. How is this problem different than the other one? Well, it's just slightly different because you notice we have an x on the outside here, where the other problem just had the 4. So when we do this problem, exact same process, just be careful. So I would recommend pause the video. If you really got the last one, this one you're going to get. Pause the video, give it a shot. Okay, here we go. Let's give this a shot. First thing I'm going to do is I'm going to sub in my infinity, or my big. So that's going to give me the square root of 9 big squared plus 4 plus 4 big divided by 2 big minus 4. Okay? Now, inside the square root, we can focus in there. We say, all right, the addition can go. We don't need the addition. So now we're just looking at the square root of 9 big squared. Well, the square root of 9 is 3. Square root of big squared is big plus 4 big over 2 big. And up here in this denominator, same idea, that minus 4 does not matter. So we're just left with 2 big. Now, you'll notice this is kind of a new scenario for us. But as long as you're not, kind of freaking out, don't panic, you'll be fine. What is 3 big plus 4 big? That's like just saying, like, what's 3 plus 4? What's 3 apples plus 4 apples? 7 apples. So this would be 7 big divided by 2 big. And the bigs would now divide, leaving us with 7 halves. Okay, so for these two problems, what's the big takeaway? Don't panic. If you have an infinity, when you're doing a limit as x approaches infinity, just sub in bigs and follow along with that big little logic just like you have on the other problems. All right, hope this helps.